So in this video, we'll continue our discussion on how to find the volume of a solid. And in this case, we're talking about a general case where the solid may not be full. Please look at the current picture. I'm actually doing the y-axis rotation for the purple part. I mean, you're trying to rotate the purple part along the y-axis by 360 degrees. And we expect that we are getting the solid, which is something like that. And if I ask you to find the volume of such a solid, you cannot use the disk method immediately because if you try to draw the horizontal part here, you're not getting a full circle, right? Because previously the disk method is based on the fact that we're actually getting a full red circle inside. So you can actually write down the content inside the integral as pi r squared, but we're not getting the full circle for the cross-sectional area. So similar to what we saw in the last video for the x-axis rotation, we have to imagine that everything is actually full inside, and we can borrow the method we learned in the disk method, right? And let me write the picture down. So you see, if you imagine everything is actually full inside, you're actually having a full solid. And for this full solid, because I, we should have the function of the curve as x equals a function of y here. And if we have such a curve by x as the main variable, and I believe you remember how to find the volume of this full solid. Because what we can do is, if you know the lowest point is a, the highest point is b along the y-axis, this volume is the same as the integral from a to b along the y-axis for the pi r square, and the r now is exactly f of y. And here we call it the outer radius, in the sense that by using this line, we're getting the outer solid. And you have to subtract the inner solid from here. So let me draw the picture. So you see, please look at my picture in red color. If you look at the picture inside the black box in the left hand side, I'm talking about the red part here. I would like you to cut it out from our full solid here. After cutting the red part out, that's the volume of the solid we want, right? And you see this inner solid itself is a full solid. So we can borrow our method in the disk method topic to get the actually the volume formula of this solid, which is the same as the integral from a to b along the y-axis. That's why it's the y integration of pi r square. And this r is actually, we call it the inner radius. And the inner radius actually is based on the inner function between the two functions. You see, this one is the outer function, this one is inner. So I call it g of y here. And basically, the volume for this picture is the same as the big one, the volume of the big solid minus the volume of the inner solid. And let's look at some examples together. So please look at the current picture now. Can you imagine what kind of solid you're getting if you try to rotate the given purple picture along the y-axis? So roughly speaking, I know that my drawing is not perfect, but roughly speaking, you're getting a solid like this. And in this case, of course, it is not a full solid. So we have to use the washer method in the sense that you have to use the outer solid minus the inner solid. And please note that it is a y-axis rotation. It means that to make sense of it, we have to do a y integration for the washer method. And let's look at A and B. So what are the A and B? They are the lowest point and the uppermost point along the y-axis because we are doing the y integration. And the lowest point is clear, which is 0. So what is the upper point? The upper point here is based on this point, which is the intersection of the two lines, y equals x and y equals x cubed. And B is mathematically the x coordinate of this point. I'm sorry, the y coordinate of this point. So you have to solve this equation. Maybe I can set them equal and you can solve it. And so x equals 0 and 1. And b is the y coordinate. It means I have to replace the value x equals 1. So basically it means this one is 1 to any one of the two lines here. So you can replace by x equals 1, y equals x becomes 1. So it means b is actually 1, right? And the remaining step is for you to write down the outer radius and the inner radius. And please think about that. It is a y integration because it's a y-axis rotation. So what is the outer line? The outer line represents this line. You use this line to generate a full solid. And this line is what? Is y equals x squared. So it means that this one is based on y equals x squared, but we need the function to be in the form x equals some function in y. So I can write it as x equals square root of y. So it means for the outer radius, it should be the square root of y. And similarly, for the inner radius here, the inner radius is what? The inner radius corresponds to the empty part that I want to cut out, which is this part. And for the solid, it is based on this line, right? Which is the inner function, which is y equals x. And let me put it in the purple color. So this line is actually y by y equals x. And this line is easy. We don't need to do any transform because I can write it as x equals y. It means that inside the bracket, I can just write y here. And that's basically the end of this volume formula. Of course, you can do the computation yourself. And let me write down the formulas here. So if you do the computation yourself and you get the final answer here as the volume of the solid that I show on the top page before. And that's the end of this video.